Okay, section 5.4 is use medians and altitudes. And the first part here, we're just going to learn the vocabulary and do some application, and we'll get into a little more advanced things with the medians in the second part. So the first part, a median of a triangle is a segment from the vertex to the midpoint of the opposite side. So if we would draw the medians for this type of triangle, which is an acute triangle, and then in a right triangle, and then an obtuse triangle. The altitude is the perpendicular segment from a vertex to the opposite side, or to the line that contains the opposite side. So here we go with altitudes. DE is already in altitude, and so is EF, because of the perpendicular already there. And then in an obtuse triangle, there is only one altitude that will be inside the triangle. And here's one that's outside, and then this altitude would be outside the triangle. So using this diagram, we're going to name or identify the segments that are each of our items: the angle bisector, the medians, the perpendicular bisector, and the altitude. So an angle bisector splits an angle into two pieces, and I can see that marked by the arches. So CG is an angle bisector, or GC. A median must go to a midpoint from a vertex. So EB is your median. A perpendicular bisector is going to go a segment perpendicular to the side through the midpoint. So my B is my midpoint there, and AB then would be my perpendicular bisector. And an altitude goes from a vertex to the opposite side and is perpendicular. So that would be FD. If BD is a median, that means AD and DC are congruent. So I can put those two expressions equal to each other. Subtract X, add 17. And then it wants to find the length of AB. I just substitute X in. AD is an altitude. An altitude means it goes from a vertex to the opposite side and is perpendicular. So that means angle ADC is 90 degrees. And it wants me to find BC. Well, BC is BD plus DC. I can substitute 20 into both those expressions. So we get 40 plus 60 minus 4, which is 96. So that was the easy part. Now we get into a little bit more complicated part with our use of medians. The three medians of a triangle intersect at a point called a centroid. If we want to talk about the altitudes, the three altitudes intersect at this thing called the orthocenter. So another vocabulary word that you need for the project. Okay? And the medians intersect at the centroid. The medians intersect at a point, again, that is called, or that is 2/3, sorry. The distance from each vertex to the midpoint of the opposite, we're missing the word side, sorry. Okay, so the medians of this triangle ABC meet at point P, and AP is 2/3 of the whole median. BP would be 2/3 of the whole median, and CP is 2/3 of the whole median. I like to also make note that you don't have to use that. You could say that AP is 2 times the shorter piece, and it's just that there's a short segment and a long segment, and they're in a 1-to-2 ratio. The other little tidbit is that AE, and we're just looking at one median, be true for all of them. AE, the whole thing, would be 3 times the shorter piece. And you'll see that I do that a lot rather than using fractions. So G is a centroid at ABC, AD is 8, AG is 10, CD, the whole length here, oops, this whole length here is 18. Wants us to find BD. Well, BD, D is a midpoint, so BD is 8. AB is then the two of them added together. 16. EG, so I know that number 3, 2 times GE, or EG, equals AG. So that equals 10. So I divide by 2, and G equals 5. Number 4AE is then just the two of them added together. Or you could take 3 times the smaller piece, which is 3 times 5. CG, well, in CG is actually the longer length. You could say that 3 times GD equals 18. So GD, which is number 6 up there, is 6. And then 2 times GD equals GC, or 2 times 6 equals 12. If, or we're actually going to do some reasoning with this. Is the BD segment, is it going to be a perpendicular bisector is it a median, or is it an altitude? So you have to recall your definitions of what each of those are. Granted, perpendicular bisector is going to be a perpendicular segment, and altitude is going to be a perpendicular segment, and a median is not. So in number 7, I see perpendicular, I see congruent. So it's going from a vertex to the midpoint of the opposite side. So that's a perpendicular, first off, it's a perpendicular bisector. Oh, and I should have clarified that it can be more than one. It's going to the vertex to the midpoint of the opposite side, so it's a median. And it's going from the vertex perpendicular to the opposite side, so it's an altitude. So this one happens to be all of them. And it's just because of the type of triangle that it is. In the second one, we are going from a vertex to the opposite side, but the perpendicular part is not at the right location. It needs to be on this side over here. So from a vertex to the opposite side, perpendicular would be an altitude, and so this is actually none of them. We're going from a vertex to the midpoint of the opposite side, so that is a median. There's nothing perpendicular there, so it can't be the other two. And now we're going to do some algebra using our knowledge of centroids and what it does to a median. So looking at CG, CG, and CE. All right. So I have CG is the longer piece. CE is the whole median. Unfortunately, this you do have to do the 2/3. So GC is 2/3. Oops, CE, sorry about that. So it takes 3 GCs equal 2 CEs. I think it's just a lot nicer to just write that out, so I can take 3 times 3x plus 7 equal 2 times 6x. Subtract 9x and divide by 3. All right, and number 11, and that's the only time you have to worry about is the longer piece is 2/3 the median. When you only have the long and the median, in an algebra sense like this, you have to use that 2/3, unfortunately. FG is the shorter piece. AF is the whole thing. So it takes 3 shorter pieces to equal the whole thing. So 3 times x plus 8 equals 9x minus 6. Subtract 3x, add 6, divide by 6. And the last one is BG. BG, which is the longer piece, and DG is the shorter piece. So 2 shorter pieces equal 2 shorter pieces equal 1 long piece. So 2 times 4x minus 5 equals 5x minus 1. distribute, subtract 5x, add 10, divide by 3. So the key is really to know those relationships between the shorter segments, the longer segments, and the whole median, and that will make these problems a lot easier.